Hey y'all! Today we will be talking about complex numbers and complex conjugates. By the end of this video, you should be able to understand what complex numbers are, perform some different operations on complex numbers, and lastly, know how to use conjugates when solving problems involving complex numbers. First, we will cover concepts students should know before learning this lesson. Second, we will go over the actual concepts. Third, we will show you some common mistakes that students should avoid. And lastly, we will work through a variety of practice problems together. Now, both real and imaginary numbers fall under the realm of complex numbers. The imaginary unit I represents the square root of -1, which is an answer to an equation such as x squared plus 1 equals 0. Now, here's a chart of I raised to the 1st through 8th powers. Notice how the result cycles after every 4 powers. This is a pattern you should keep in mind, for it is very helpful, especially when dealing with larger powers. Now, the standard form of a complex number is a plus bi, where a is the real part and bi is the imaginary part. However, keep in mind that b is still a real number, and bi is a pure imaginary number by itself if b is not equal to 0.
When adding complex numbers, combine like terms, which means adding the real parts together and the imaginary parts together. When subtracting, be sure to distribute the negative to both the real and imaginary parts of the complex number you are subtracting. When multiplying, multiply them like how you would multiply two binomials.
In division, it is very important to use conjugates because they can turn a complex number into a real number, which is useful when working with fractions. To find the conjugate, simply change the sign of the imaginary part of the complex number. In division, you multiply both the numerator and denominator by the denominator's conjugate. Now, let's go through an example of conjugates so you can see how exactly a conjugate helps, especially when doing division. So, 1 plus 2i has a conjugate of 1 minus 2i. Now, multiply them together and you get 1 minus 2i plus 2i minus 4i squared. Negative 2i and 2i are opposites of each other. And you can cancel negative 2i and 2i because they add up to equal 0. Now, I squared equals -1, so your answer is now a real number. Notice how now, if your answer were a denominator, it makes the question so much easier to simplify.
When graphing complex numbers, use a coordinate plane. In this case, the x-axis will contain the real numbers and the y-axis will contain the imaginary part.
Now, on to some common mistakes students make when working with complex numbers. First of all, standard form is a plus bi, not bi plus a. And when squaring a complex number, you cannot simply distribute the square to both parts. Rather, you should treat the complex number more like a binomial.
To leave your simplified answer in standard form, distribute the denominator to both the real part and the imaginary part of the complex number. Now we'll do some practice problems pertaining to the concepts you've learned. Given the quantity of 5 plus 8i minus the quantity of 4 plus 10i, first distribute the negative to the quantity of 4 plus 10i, then add like terms. 5 minus 4 plus 8i minus 10i simplifies to 1 minus 2i. Next, simplify 5i times 8i. First, multiply the numbers 5 times 8 followed by I times I or I squared. Simplify to 40i squared. Since I squared equals radical -1 times radical -1, your final answer will be -40. Quick quiz, what is the conjugate of 8 minus 12i? Your answer should have been 8 plus 12i. Next problem, simplify the quantity of 5 plus 2i over the quantity of 3 minus 7i. Multiply both the numerator and the denominator by the conjugate of 3 minus 7i, which is 3 plus 7i. Simplify until you get 1 over 58 plus 41i over 58. Here's the last example. Find the distance from 3 plus 2i from the origin. Use the Pythagorean theorem, x squared plus y squared equals r squared, where r is the distance from the point to the origin. Therefore, 3 squared plus 2i squared equals r squared. Simplify to 9 minus 2 equals r squared, and r equals radical 7. Now you should know that radical -1 equals I, a complex number has a real part and an imaginary part, and to simplify a fraction with a complex number in the denominator, multiply both the numerator and the denominator by its conjugate.
created using Powtoon.